Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. On this episode, I'm joined by my co-founder Drew Banin, as well as Nick Handel, co-founder and CEO of Transform. Transform's open source project, MetricFlow, the leading headless semantic layer in the modern data stack. And we, DBT Labs, just recently announced that the two companies were joining forces. In this episode, you'll hear Nick talk about his almost decade-long love affair with semantic layer technology, all the way back from his time as a data scientist at Airbnb. We'll also talk about semantic layers in general and what the combined DBT plus MetricFlow future looks like. Personally, I've never been more excited about the promise of the DBT semantic layer. Since launching into public preview in October, we've seen a huge amount of interest from the community. I'm pumped about MetricFlow accelerating our roadmap for it literally years into the future. Without further ado, let's get into it. Drew and Nick, I am very excited to have you both on this episode of the Analytics Engineering Podcast. This is going to be a fun show. We're going to talk about the semantic layer. But before we really get into it, I want to give both of you the opportunity to introduce yourselves. I mean, probably both of you need no introductions, but I just want to give our audience the opportunity to get familiar with your voice and your background.
Hey, Drew Banin, one of the co-founders at DBT Labs, wrote a lot of the early open source DBT code, spent a lot of time in the DBT Slack, and these days head of product thinking about bringing the semantic layer to the world.
Hey everyone, I'm Nick Handel. I was one of the three co-founders of Transform. Transform was building a semantic layer, and now I am a director of product at DBT Labs working on the semantic layer. So really excited to be here.
Let's go back in time. There's a world that I think all three of us are excited about creating, but there's a small number of companies that started to live in that world, or at least some facsimile of that world, several years ago. Nick, you worked at Airbnb.
Yep.
You both used Airbnb's version of, would it be fair to call that a semantic layer, or would you call it a metrics tool?
Yeah, I wouldn't say that we knew we were building a semantic layer, but I would say that starting in 2014, we were working on metrics tooling. And It eventually definitely became a semantic.
So I'm really interested in exploring that experience a little bit, because I think that most people actually don't know what it is like to work, including myself. Like, I have not worked in an environment where a set of integrated tooling, including a semantic layer, existed. So I'd be curious for you to just paint a picture. You know, what were the problem sets that got internal tooling people to work on this problem? How far did you get? What did it feel like to be a practitioner in this environment? All of it.
I think it's probably best to just kind of go back to 2014. I joined Airbnb's growth team as a data scientist. I was the second data scientist on that team. And that team had kind of established a practice of that build, test, learn, experimentation cycle. That was a really big part of what that team was doing. And so as a part of that, we were trying to run as many experiments as possible. And every time we ran an experiment, we would go and write a bunch of queries. And oftentimes those queries ended up looking really similar. And they were really just trying to calculate metrics. And so basically a week after I joined, somebody on the data platform team said, hey, I've been working on this little tool. It spins up a few jobs based on some YAML files, and it outputs a set of metrics for your experiment. And I thought that was really cool, because I was writing a bunch of SQL. It was repetitive. Every single time I'd have to make these small differences to say, like, this experiment, it was launched at this time. It's, a user level experiment or a device level experiment or something along those lines. And I started using this tool, and it was just magical for me, because it really unlocked a huge amount of productivity. I went from running maybe 1-2 experiments at any given time, just because it took about a week to do the analysis for each one, to running 15 to 20 experiments at the same time.
Okay, so this, I feel, is a little bit mind-blowing, because not that this tooling would make you more effective, but that it seems like the data analysis component of the experimentation workflow was actually the bottleneck.
Yeah.
Can you say more about, like, I would have assumed that the engineering part of the experimentation process would be the bottleneck.
It depends on what you're building. I think if you're building some very significant piece of infrastructure and you're trying to test that the page load time decreased by 100 milliseconds because we switched over to this new render and it took us a few months to build it, then sure. But what a growth team is doing is oftentimes, I think this is probably underappreciating the work of growth teams, but it's, changing button colors and changing copy and relatively small changes that engineers can do really quickly. But one of the things that I learned running all of those experiments is that our product intuitions are very often wrong. The best people will be able to get the right bet on product maybe 60% of the time. And you learn that by running experiments because you make a hypothesis, you run an experiment, and you just see that it doesn't always turn out exactly like you think. And there's a lot of interesting stuff in there. But yeah, I was the bottleneck. My work was the bottleneck. And I immediately felt that when I joined the company. And it's part of why I latched on to that tool, because I was like, this tool is what allows me to no longer be the bottleneck. And it's what allows me to actually do the interesting work, which is what happens when you get all of the metrics and you look at them and you're, actually kind of experiencing the kind of analytical workflow.
On some level, if you're running repeated queries, if it's just you, probably a semantic layer is not actually going to help you from a speed perspective. That's my instinct, because you have to do all this work configuring it, whatever. And copy paste turns out to actually be quite fast if you want to run another query that's just like the query that you just ran. So my guess is that at least some part of the efficiency gains you were seeing here were because you were trying to do this work with a set of other people, and the fact that you were all contributing to this repository of metrics was what was buying you the velocity. Is that true or false?
So I don't think semantic layers are great at asking questions of net new metrics or dimensions, but they are good at asking net new questions of the same metrics or dimensions. And so what we were doing was we were asking net new questions of the same metrics and dimensions over and over. Actually, dimensions came a little bit later. Originally, we didn't have that concept, and we just made more and more metrics for every single kind of split of a dimension, which when it ballooned to thousands of metrics, we said, hey, we probably need another abstraction in this system. But yeah.
It's probably started out fairly small. I get the sense that you were at least reasonably early in the usage of this tool. Go forward in time a little bit. What does this start to feel like when most of the data scientists at Airbnb start to latch onto this?
Yeah, I think that there's one moment that I can really point to where I don't think that it happened suddenly. It happened pretty gradually, but kind of fast forwarding to maybe 2015. So we're maybe 12 months into adopting this framework. We have thousands of metrics. We're adding all kinds of new features to just, calculate different types of metrics or calculate dimensions. So we didn't have to redefine all of the metrics for every single dimension. And I still remember a product manager, Lenny Rachitsky, who now writes a great newsletter on product management, sent me a message saying, hey, one of your experiments is moving my metric. His metric at the time was what percentage of listings on Airbnb were instant bookable. And so he was trying to increase that. And I was running an experiment on login, and I made it so that more people were logging in. And that meant that more people could see instant bookings. And so it was this kind of effect that I didn't expect to happen. It wasn't a part of what I was trying to do. I was just trying to make login a better flow. And it actually impacted his work. And so he reached out to me and he said, hey, how do I help you get this launched? This is really good for my metric. That story is interesting because what it really highlights is two completely different parts of a company that are trying to optimize for different metrics that are actually using this kind of plane to communicate, to figure out what's going on, to understand these, cross-team effects. And that's honestly one of the hardest things about doing data work, is that you can do all of the work to optimize for your, specific domain, but it's very hard when you have to do all of this analysis to prove to other teams that you're not impacting their metrics negatively, et cetera. And so what this allowed us to do was their team defined a metric. It was a part of my experiment. And because of that, they got to see the impact on their work. And that I think is pretty special. And it actually led to a lot of interesting insights where teams were learning from the work of other teams because they knew that the metrics that were being calculated were exactly as they had defined them. So they could trust in the numbers that were coming out of this analysis.
I want to ask one more question here, and then I want to zoom out a little bit. We're talking a lot about workflows that, I guess there's maybe two primary workflows. There's the define a metric workflow, and then there's the analyze a metric. And my understanding is that even back in the kind of time frame that we're talking about, the define a metric workflow was in code. I think it was in YAML. Is that right?
Yeah.
And this was checked into Git somewhere, right?
Yep.
And then what did it look like to do the analyze a metric workflow? Like, where was that happening?
We had, at least for the experimentation use case. And so it's important to note that this was before Minerva. So at this point, the metrics, we called it metrics repo. The metrics repo was really just focused on the experimentation use case. Although there were several data analysts who created fake experiments in order to have it generate metrics for them because they didn't want to write the SQL, myself included. That analysis, I think that at the time, I don't think that we existed in a world where the experimentation was benefiting from this, centralized definition of metrics, and the analysis wasn't yet benefiting. And I think that is kind of the lead into the next generation of metrics at Airbnb, which was this incredible data scientist and then product manager joined us, and they came over from LinkedIn. And at LinkedIn, they had this, I think it's called Unified Metrics Platform or Universal Metrics Platform. UMP is and so they had seen what it looked like at LinkedIn, and they saw our experimentation framework and decided that, it made sense to make this a more generalized tool. And at the same time, people were hacking it to try and pull metrics out of it. And so that's what led to Minerva. The experience of using Minerva today is something that I'm not extremely familiar with because I've been away from it for 4 years now. But I can tell you that I think that the experiences are very similar. And I know that the technologies have evolved, but there are some differences between the approach that we took at Transform and kind of the experiences that we saw Minerva deliver. And kind of there are reasons for why we deviated from that.
Sure. Okay. Let's zoom out from the history for just a second. Drew, I want to get you in here. We've just learned a little bit about how a metrics layer came into existence, what it felt like to use it, what the benefits were. We kind of skipped right past the definition. What is a semantic layer? What are the necessary components of one?
For me, it starts with the concept of a metric, right? You want to understand the business. When we talk about semantics, it's getting very specific about the meaning of something. And frequently, the places where folks are most misaligned within an organization is about the meaning of ARR or the meaning of a customer versus a user, an account, contact. And so semantics is, creating precision around these things, and then consistency. And the idea of a metrics layer or a semantic layer is about, to me, exposing that to a lot of other tools. So it's not enough to just see the number somewhere. It's about actually getting access to it in the tools that people use, whether it's BI or other kinds of data applications.
I'm going to ask the naive question, and I'm sure that you have answered this a million times. I would love to hear the best answer that you've come up with, because I end up going into, whenever I get asked this question, I end up going down deep rabbit holes, and somebody has to rescue me. Why isn't a semantic layer just a series of database views that sits on a bunch of DBT models?
So this is pretty common. And Tristan, I don't know if you remember that we did this back in the consulting era.
We've done it.
There was a metrics package. We thought this is going to be a big deal. Tables in a database. It is here's the term, an explosion, a combinatorial explosion that you get. So Nick, you mentioned the importance of dimensions and how there's this important primitive. If you have a metric like number of customers and you want to slice that by region and plan and sign-up period, where sign-up period can be day, week, month, quarter, year, to actually represent all of those different combinations of ways of looking at the metric, you end up getting it would be a lot of different database views if you tried to make different database views for all these things. And that's not ergonomic. Or two, you could stick it all in one table and kind of like, make a cube basically. And then you would get, depending on the number of distinct values for each of these different dimensions, you get this combinatorial explosion where there would be more rows in the database than there are, like atoms in the observable universe. And that is not good.
Isn't it, if you have 100 dimensions on a single metric, isn't representing all the possible combinations that somebody might want to slice by? Isn't it 100 factorial? Or is it 99 factorial?
It's one of those two.
Yeah.
Well, I think it depends on the cardinality too, in terms of number of rows. So there's number of rows and the numbers of different like distinct tables you would have to create in both of those. If there's low cardinality, it doesn't matter that much from a number of rows perspective. If you care about, say it's countries. Okay, there's, a couple hundred countries. If it's cities, you could have thousands of those, and all of those cities crossed by all the different tiers that exist in your product, and crossed by all the months in which someone could sign up from those countries and those cities and those tiers. You just get billions or trillions of rows.
So I'm going back to when I remember doing this on consulting projects years ago. But the reason that you don't want to just write queries on top of fact tables is that there's nowhere that your example was number of customers. That logic isn't being defined anywhere. Now, maybe that's a count star on the new customer event, but like somebody has to actually know that.
Right. So you could write one of these queries in a BI tool, right? Select count star from customers table group by sign-up month, right? The compulsion to make this a table in a database is that you don't have to define that specific aggregation. A count star is not a very complicated aggregate to define in a BI tool. In fact, many of us have done this many times. The problem is that some metrics are more nuanced. So for instance, for an e-commerce company, if you want to look at revenue, the canonical example is make sure to exclude orders that are returned and take out the tax paid. And then there's other intricacies like, can I name drop people on this podcast? Do we do that?
Sure, go.
I already did.
Okay, TJ Murphy once tweeted about how they recorded returns as creating a new order with a negative order total or something like that. And so, okay, there's going to be like intricacies of the data that you need to encode in the metric definition. And if you look at select count star from customers, you start to think, we can just do it in the BI tool. But now you have a lot of different BI tools and other places you access data and more complicated metrics. And then version controlling that and testing your assumptions becomes really important.
I would even argue that select count star from customers is complicated because the place that you do select count star from changes over time. Like originally it's fat customers and then it's like fat customers V2. And if you are not perfectly up to date, the world will have moved on without you and you're still using some old table that no one actually uses anymore.
Totally. I mean, this happened to us when we shipped a pricing change in December and we used to have a plan called Team and now it's called Team 2022 or something like that. And so depending on exactly which report you're looking at, for a moment, you would actually see the wrong number. So that's pretty quick to fix given that we use, the semantic layer internally and have all these things defined in DBT, but it's real.
In order to bring this stuff to life, Nick, what are the pieces of technology that one needs to build? Because, okay, we have this problem of combinatorial explosion. We can't just make infinity pre-aggregated database views and tables. How do you fix that? What technology do you need?
So I guess just to set a little more foundation there, when I think about data transformation, I think about these three pieces: cleaning the data, modeling the data, and then serving the data. And most people's DAGs include all three pieces. You're doing a bunch of cleaning, you're building a bunch of kind of nice, clean tables. If you're using Kimball, you've got your facts and your dims and you're, shooting for third normal form, but you end up with, something slightly different and everyone does, and that's okay. But you typically end up doing some kind of aggregation in the warehouse, whether you want to or not, right? And that's kind of what Drew is describing. And you do it because you want your serving layer to be really fast. And so you pre-join tables and you pre-aggregate stuff and you create summary tables and all of these kinds of things. And when you do that, you're defining a bunch of different logic. And I would say that broadly, that final process of defining that logic is doing denormalization, right? You're joining, filtering, aggregate. And when you do denormalization, you're compressing data. You're taking a big table, a bunch of big tables, and you're turning it into something smaller that is more consumable, right? And sometimes that work happens in the BI tool, and sometimes that work happens in the data warehouse. And a big part of what the semantic layer is trying to do is to say, no, it's not going to happen in both of those places. It's going to happen in one place, and it's going to be consistent. And we're going to make the logic as dry as possible so that I can say, I go to customer's final V4 and I do account star. And that is the definition of customers right now. It might change. And then in my downstream tool, when I look at a graph of customers, I know that it's going to match across all of the different applications of data that I have in my company. So perfect. How do we do that? There are a few different pieces of technology here that matter, but the core of it is the ability to generate SQL that does that work. And so that is what the project that we've been working on for a while now, MetricFlow, does. And it's a complicated problem. It's not as simple as select a dimension and do a count star from this table and then group by that dimension.
I mean, it can be that simple, but
much more complicated process because you're trying to do everything that is encapsulated in that process of denormalization, all of the joins, the filtering, the aggregation, et cetera. And it's a very nonlinear process sometimes to build those queries.
So you said that it's not as simple as doing a count star on a table. Sometimes it is. Sometimes it's very simple. But I think it would be really interesting to understand, like, what does a really complicated query look like that MetricFlow generates? Like, what's a really gnarly query look like?
Sometimes it absolutely is. And it's really good if your North Star metric of your company is a query that is that simple, because it means that anyone can go and ask it and they'll always get it right. And, that's really important. But the reality is that when we do analysis, you can't just select count star from the company's big table and answer your questions, right? Like, that's not enough. It might be enough to say the business is doing well because the number is, up at the right, but it's not enough to know why it's doing well. It's not enough to know the nuances. And so when you want to do that kind of analysis, typically there are kind of two types of questions that you can ask, right? And Tristan, you and I have talked about this. You can either ask a time series question. And when you ask a time series question, you almost always want to either compare two metrics, or you want to compare a metric across, various dimensions. And so when you want to do that, sometimes you need to pull a dimension in from another table. And in that case, a part of getting that metric definition correct is actually doing the join correctly between those two tables. And so if you want to calculate two metrics, sometimes it's quite complicated. You have to go and calculate both of those metrics. Maybe one of them is not simple. Maybe both of them are not simple. So you have to do the SQL, you have to do the filtering to construct that metric correctly. And then you need to join them across the time series. And then you need to be able to kind of, look at that unified data, right? So the second type of question is, I would like to understand an entity and I want to dig into that. Like, I want to know about a user and I want to know a bunch of different metrics about this user, right? I want to know the last number of purchases in the last 90 days, the number of times they've contacted customer service, et cetera. Whether, you could ask a dimension question like, are they a part of the, team or the enterprise plan, something like that. And oftentimes those types of questions lead to the most gnarly queries because you're pulling metrics from, tons of tables. You're pulling dimensions from tons of tables. Oftentimes dimensions and metrics are not coming from the same tables. And you're pulling it all in and trying to figure out how to, do 7 joins in a query. And those are the kinds of questions people ask. So you need to be able to generate that SQL.
What's a big SQL query? Like number of lines? in MetricFlow response world?
Well, there are some optimizations. I'm gonna go with the optimized lines of SQL. I think hundreds of lines of SQL is perfectly normal and it's not unreasonable. And we've all, as analysts, we've all written 100+ lines of SQL to answer relatively simple questions sometimes. It's just the way it is.
Yeah.
And you don't want to encapsulate that logic in a model because you're just going to be doing it over and over and over again in slight variations that are different. And I know because I did that also. I put basically the same query across like 7 BI dashboards and had to figure out how to maintain that.
The deeper we go into this conversation, the more I feel compelled to draw on a set of priors that many people listening to this will have. But before I go there, I want to provide a caveat. So this is the part of the conversation where I say the word lookml. And I want to say that as a person who has used, I've had user accounts on at least 50 different Looker instances. I've written hundreds and hundreds of hours of lookml in my life, and it has provided tremendous benefit to me. So I don't bring up lookml so that we can say like, lookml, that's not what I'm interested in doing. But there are some ways that there's, thousands and thousands of humans out there that know how to write lookml. There are some ways that MetricFlow has made different choices about how to generate SQL. And they have you have to have a different mental model for how you ask MetricFlow questions then. So one of these, the one that's really stuck in my brain is the way that MetricFlow does joins is a little different than the way that lookml does joins. And the thing that in particular I've always thought was a really core part of Looker was the symmetric aggregate, the thing that makes sure that you don't have to think too hard about fan outs. Anyway, I'd be interested in any of your thoughts on different choices that MetricFlow has made and why, and where does it get you as a user?
I think lookml is amazing. It has accomplished so much. It's brought the semantic layer to the forefront of, so many discussions in the kind of modern data world. And that's really exciting. It means that people know what we're talking about, right? Like so many people have firsthand experience with the tech that we're talking about building. And that's awesome. And we should always be trying to improve and build on previous generations of technology because we all benefit in so many ways because of that kind of work. And so I think that this approach to joins actually comes from that story that I told about experimentation. We thought about the world as entities because every experiment is run to the granularity of a subject, right? A user is seeing either experience A or experience B. And so we built this whole framework where we captured a bunch of entities and we captured metrics that could be calculated for those entities. And so when we added dimensions and when we started thinking about where do we pull all of this data together at Airbnb, we said, well, when I go and I construct a join, there are really two things that I think. I think about the two keys, which are basically entities, right? A user ID and a user ID in two different tables. And they have different representations, right? In a dimensional table, maybe it's the primary key. And in a fact table, maybe it's a foreign key. And so first, the key. And second, the kind of period of time, right? Maybe you have a dimensional table and it's an SCD table, or it's got date partitions or something along those kind of lines. And when you construct a join, you basically think about those two things. You say on user ID equals user ID and DS equals DS, or maybe you don't do that depending on the kind of model. So that's great. Now, when we started thinking about this and when we kind of started thinking about what a semantic layer could look like when we set out to build MetricFlow, we wanted to kind of lean into that understanding of how we build joins. And it is important to note that the worst part about semantic layers is how much logic is created and how difficult they are to maintain, right? And that is a challenge that I've heard over and over again about companies' experience using lookml for many years. And it's a real challenge. It's like, it is a hard problem to solve. And so what we decided to do was to focus on this entities abstraction. And I think that it replaces the abstraction in lookml, which is the explorer. And it basically means that the user doesn't have to specify all of the individual relationships. If you think about, an entity relationship diagram, like a graph of tables and the relationships between them as the edges. All of those edges are pieces of logic that must be maintained in lookml. And I think that it's one of the most difficult things to maintain because it's not as natural as just looking at a table and saying, well, these are the columns and these are the measures and dimensions that I produce from those columns. And that's like a very clear one-to-one mapping. Those relationships are much more complicated. And so the way that MetricFlow does this is it basically has representations of these, various entities, and we call them identifiers. And there's a concept called entities and roles beneath that. But we use them basically to create the join paths between these different tables. And so when I get asked a question, or when MetricFlow gets asked a question, it says, okay, what are all the tables that I need to go to get at this information? And then what are the join paths between those tables? And how do I construct a SQL query that is as efficient and as legible as possible? And that the really special thing about that is that it allows you to completely avoid symmetric aggregates because you can choose which tables are on the left or the right side of queries. And because of that, you can avoid doing queries that just don't make sense. You can avoid joins that don't make sense. But if you build a framework where people manually define these joins, then they can define joins that are really hard to basically lead to fan out and require symmetric aggregate. It's a very long answer.
Nick, I think that's on the money from our historical perspective. And the thing we always talked about in the early days of us building a semantic layer was the difference between the looker style join and then aggregate versus what we kind of built into the DBT semantic layer, which is aggregate and then join. And if you aggregate tables up to the right grain, then you can see different metrics coming from different tables. Just join those together on shared dimensions. Is that also how you think about it?
So can I jump in with a really quick grounding this in a very specific metric? This always used to drive me crazy. Customer acquisition cost is a very challenging metric to calculate sometimes because you have your number of customers part of that, and then you have your cost part of that. And oftentimes, if you've ever done any type of marketing work, you can't directly attribute a number of dollars to a specific customer ID. There's just like not a join key there. And so what you end up having to do is you have to calculate customers and you have to calculate dollars, and then you end up aggregating them at the day or week or month or whatever level, and then you join those two metrics together on the time grain and not on an individual ID. And I think that is there are many, many metrics for whom that is the kind of the only natural join key is the date.
I mean, this is kind of an extension of Drew's question.
Yeah.
I feel like the answer to Drew's question is that, like, yes, sometimes, but the really special thing about MetricFlow, like most of the time, actually, the really special thing about MetricFlow is that it creates a query plan in an abstract way with a bunch of different nodes that do various data transformations. It's not thinking about SQL, and it then can decide and optimize what is the best way to do this query. How do I, make this the best query that could possibly be written to answer this question that I'm being asked? And it then moves those nodes around and takes that and then renders this. And so it could do both. It decides, based off of the inputs, how to write that query in the most efficient way.
Nick, one challenge we're going to have is rewriting MetricFlow in Jinja.
Okay.
Yeah.
There was a look on your face there for a second, Nick. I think Drew got you. Drew, there's going to be some folks who have followed this conversation for, coming up on 2 years now. I think that there's been a subset of modern data stack users who have been following the semantic layer conversation. And those folks already get it. They've just listened to us talk at each other for 40 minutes, waiting for me to ask this question, which is the only one that matters, which is, what is going to happen from here forwards? What's the plan? When are we getting the combined stuff? Now, we're recording this on March 3rd, roughly a month after we announced that Transform was joining forces with us. So I'm sure that we've had enough time to figure out everything, right?
Yeah, we've got it all figured out. Monday, it'll be ready. So, okay, the great thing is there is a pretty clear integration point between this amazing query planning metric-enabled MetricFlow Python library and DBT. There are a couple things to figure out in terms of how we, support all the capabilities of MetricFlow in the metric definitions, inside of dbt schema.yaml files. I think that we can right some of the wrongs that we've made in the specifications as a part of this process. So that's one side of things, like actually updating DBT's knowledge of what a metric is and how metrics relate to entities and other metrics, things like that. Another part of this is integrations. So up till this point, we have only shipped support for Snowflake. We are going to ship support for other data platforms as well. So that part's happening concurrently. That'll help get a lot more of the semantic layer out into the world for folks on other databases. And the final big piece of this is the actual interface for querying a metric. And this is a place where we've got a couple different options, but I can tell you with a lot of confidence that nobody's really happy about this metrics.calculate macro in its current incarnation. And I think there's actually some stuff that we can do there to make it a lot easier to query metrics from, your BI or SQL tool. So we're thinking that over the next 3 to 6 months or so, we should be in a place where we can make the changes required to DBT. We can support new interfaces for querying those metrics, and we'll get support out the door for other data platforms. And from there, we just got to keep working on making these great integrations with some of our partners, other folks that are building really exciting things on top of semantic layers. They'll have more capable APIs to integrate with, hopefully over the next 3 to 6 months.
Can I pile on there and just say that it's pretty rare that you have two teams working on technology separately and then you bring them together and everything is just perfectly aligned. And I wouldn't say that it's like perfectly aligned, but it's pretty remarkable how complementary all of the work that the two teams were doing. And I think that it's leading to what I think is going to be a pretty smooth kind of path. And I think it takes time, like it takes time to do the engineering work, but I am really excited for the product that we're going to be able to release. And there's a lot of great work that we can do with our partners, as we kind of move towards that to get them ready.
I want to go further out into the future. Let's leave behind any sense of our knowledge of near-term ship dates and the delivery schedule, anything like that. Let's go like 24, 36 months out into the future. What does the world look like? How are practitioners working differently? How do companies interact with their data differently? Now, certainly in 36 months, the idea of a semantic layer will not have taken over the entire universe, but there will be companies for whom this is now making really big changes in the way that they interact with data. What does that look like?
I think we've seen this kind of, let's say, transformational effect with DBT to date. So if you cast your mind back to 2016, 2017, you couldn't really just build a BI experience that queried tables and showed you really great charts and dashboards, things like that. There was this like baked in assumption that you would have to do some sort of transformation. It was inevitable that you'd have to do some sort of transformation in order to have a table that is ready to analyze. So we saw that with, Looker PDTs and Mode Analytics had some sort of create a table and schedule.
I mean, go back further than that. You had to build a whole local file storage caching layer to make the queries fast. I mean, you had to build a BI tool plus a database.
Of course. So to me, I think that the big long-standing impact of this work is going to be that people building tools can start with a new set of assumptions, which is that all the very important aspects of an organization, the metrics, the entities, how they relate to each other, these things are already defined. And the challenge is not, how do we create a really good interface for people to define this logic? It is, how do we create the best possible experience for interacting with it, understanding it, sharing it? And I think it kind of shifts us up this pyramid of needs, if you will. And I think that there's going to be new types of tools that assume that you will have a semantic layer from the jump, some assumptions they will make. And I think for the people using those tools, it will better connect the actual work that they're doing day to day to the experience of interacting with data. So less open up a link to a dashboard and much more like see that data in context in the place where you're already working.
I totally agree with that. I think that there are so many companies in the past that have said, I need to build a lightweight semantic layer into my product in order to accomplish product experience that I want to deliver. And, it's catalogs, experimentation tools, BI tools, analytics tools, activation, reverse ETL tools. Like they all have thought about the concept of metrics. They've thought about dimensions. They've, potentially tried to build SQL. And it's really, really hard. It's a hard problem. and having this kind of foundation that allows companies to just from the beginning say, I am going to build the best in class version of this product on top of a solid foundation of metrics, I think is going to lead to much better, much more kind of, domain specific data tools in the next few years. There's also the experience that the analysts have who use this. And I think that's also an interesting thing to talk about. Today, I think part of the role of an analyst is to do a lot of translation work. They interact with the domain expert in the business. They go back, they write some SQL, they show some data. That person asks follow-up questions. They're acting as this translation layer between the data warehouse and, the person who's trying to make decisions and understand and do analysis. Everyone is capable of doing analysis. Very few people have the ability to freely ask questions and see responses and have that kind of flow to just do analysis and make decisions. And I think that what this will enable with some of those new kind of more dedicated product experiences is that the analysts will actually be freed up from doing a lot of that translation work, and the metrics and dimensions will just find their ways into the tools. And instead they'll get to focus on the really difficult analysis, the stuff that is really what enables the business to discover new opportunities. And, it requires disentangling complicated data. And that's the kind of analysis that I think analysts sign up for and they get excited about. And then they join companies and their jobs come being this translation layer. And I'm really excited to see that because it's a real skill that I think people don't have the opportunity to flex enough of.
This makes me deeply frustrated because this is just the beginning. We're just scratching the surface of the interesting things that we could talk about, but we are about out of time. We didn't even get to talk about ChatGPT and its how it plugs into the semantic layer. I mean, now no one is going to listen to this podcast episode because it doesn't mention AI. It's no, I'm kidding. But there are like a million interesting implications for how does this impact people's jobs and so much more. We will have lots more to say over the coming months as we are behind the scenes integrating MetricFlow into the DBT semantic layer. But Nick, it's great to get you on and have this conversation early on in the process.
Thank you both. It's really fun to be here. And here means on this podcast at DBT, working on this in this moment. This is a really, I think, exciting time to be in the world of data. So thanks.
Thanks, Nick.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.